Lynn Godley is an artist who's obsessed with light. In 2011, she incorporated it into a solo show, and it made her see a whole new potential in her work.
The show was called In Flight, and we filled the gallery with all of these 2 by 2 foot images of birds. They were charcoal drawings. And we fed fiber optics through the imagery, so all of these images had pixels of light along the edges of the wings and the tails.
Fiber optics are these thin strands of glass or plastic with tiny lights at the tip. They're basically how the internet works. The pulses of light are transmitted as information, and besides being much more powerful than broadband, the pulsing strands are actually quite beautiful. They kind of look like fireworks.
And about 2 weeks into the show, I get a call from the curator, and she said, people are behaving strangely, and just thought you might want to know this, that they were coming into the gallery. There weren't any benches in the gallery, and they were sitting on the floor, sitting down and just staying in the gallery for up to 3 hours and returning multiple times. They just wanted to be in the space and to keep coming back.
Intuitively, this made sense to Lynn. After all, she was drawn to working with the light.
There is a physiological draw towards light. There's a physiological draw in our bodies towards dynamic light, sparkling off water, et cetera, et cetera. And so somewhere along the line, I really have become obsessed with using that, as part of my medium. In a piece of static artwork, in a photo or a painting, et cetera, you're really talking about, color that is created by pigment. And when we're talking about color in new media art, you're talking about color that is created by mixing light.
Lynn decided to push on this experience. Could light do more than just make people stop and sit for a while? Could it alleviate our suffering, make us healthier? And she isn't the first person to wonder this. Over the centuries, people have gotten obsessed with this idea that we can harness the power of light and use it as medicine. And not just any light, colored light. Science is full of these attempts, and yet the question remains, why are we so drawn to it? Why do we think it can heal us? And is there any truth to it? From the Science History Institute, I'm Alexis Pedrick, and this is Distillations. Chapter 1. The Guy with the Blue Glass. There's a long history of alternative medicines that use colored light, and it all started during the Civil War.
As is often noted, probably as many or more people were dying from illness and field conditions than from the combat itself.
This is Paul Collins, an English professor and author, and he tells us that this is the era that brought us embalming, anesthesia.
We were finally starting to get doctors and nurses washing their hands and cleaning their instruments and things like that. This was sort of an era where people not only were seeing very significant advances in public health, but also because of those advances, I think they were more credulous too. So many things seemed to be within reach that you could kind of believe almost anything, like applying copper plates to people's feet to draw out poison.
Or the healing powers of colored light, a topic Paul Collins discovered by accident while researching his book, Banvard's Folly, 13 Tales of People Who Didn't Change the World.
I was in the basement of the library at the University of California at San Francisco. And this one day, I literally just saw this very pretty blue binding. It actually really stood out as sort of this bright blue binding that stood out from all the other old books there. And so I pulled it out and opened it up, and all the printing on it was in light blue as well, like this light, almost violet kind of blue. And I just went, what is this?
It was an 1877 book called The Influence of the Blue Ray of the Sunlight and of the Blue Color of the Sky by Augustus Pleasanton, a Civil War general.
He'd become interested in the idea that not only was light in general this sort of medical panacea, but that blue light in particular was.
Augustus Pleasanton proposed that isolating blue wavelengths from the sun could help plants grow. Now, he didn't have scientific or medical training, but that didn't stop him from diving into endeavors that required them with gusto.
He really put his all into things. His initial career was in the Army, but after he left the Army, he started a law practice. And so that was his professional capacity, was basically as a military officer and as a lawyer. But he was a man of great enthusiasms. And so he read a lot, and he was very interested in the sciences, and in particular with optics, with reading about things like photography, reading studies about light, and also very interested in medicine and health.
Pleasanton's adventures in blue light began when he built a special greenhouse at his home in Philadelphia.
Every eighth pane was blue glass, so that the inside wouldn't be too heavily shaded, but there would be just a little extra kick of blue coming in. And he planted grapes. In the first year, of course, they didn't yield anything. By his account, at least, in the second year, when he had someone come by to look at how they were doing, they had this fantastic yield. He had 1,200 pounds of grapes. And I should add, this is all happening as the Civil War is starting, and as he's in charge, among other things, with like helping to defend Pennsylvania. So I guess this is how he would unwind. This was clearly a labor of love for him that he'd been spending years on.
He was so convinced by the grape experiment that he applied for a patent.
And a patent examiner came up from Washington to look at his work, and apparently looked at it and said, "Wow, great job." And so he was awarded a patent for that.
This made Pleasanton extra confident about his ideas, and he decided to branch out from plants to animals. If his grapes grew better under blue glass, then maybe his livestock would too. So he built his pigs a barn with glass in the roof.
He basically put in skylights, and in one side he put in clear glass, and the other side he put in some blue glass, and reported these wonderful results in the blue glass side. And I probably should point out that one person who visited him, who was actually very admiring of him in general, he said, "Well, the side that he's got the blue glass on, he's taking much better care of." The pigs are getting a much better deal there. So the funny thing with Pleasanton is he seems like someone who really genuinely believed in what he was doing, but he did not have sufficient grasp of like a controlled experiment.
At this point, maybe you can guess what comes next. From grapes to pigs to people. He claimed that patients suffering from ailments like rheumatism could improve after sitting under blue glass, and that tumors would shrink from the light.
I think Pleasanton had some health issues himself, which he attributed getting better to being under this glass. And of course, one of the problems with that is that he might have been entirely correct that people were improving, because if you spend some time relaxing and out in the sun, that's probably not an entirely bad thing. And he was probably not providing negative examples where it didn't work. So yeah, I think he was quite sincere about that. But he had this anecdotal sense that it seemed to be helping a number of people that he knew, and it had helped him and his own health. He really just thought it was going to be this tremendous medical advance.
For years, Pleasanton told everyone he could about his blue light therapy.
For almost all of that time, basically nobody was listening to him.
But then something happened. A newspaper in Chicago published an article about his book. Now, the article happened to be written by a friend of Pleasanton's brother. Small world, who can say what really happened? But the point is, other newspapers picked up on the story. And that was it. Blue mania had arrived.
And within a few weeks, it had become a thing. There was a run on stores for blue glass. People were buying sunglasses with blue glass. You could get parasols with glass beads hanging off of them. Prams, for babies, had blue beads and little blue glass panels installed in them. There were like streetcars that had blue glass put in them. things like that. So I think it looks like an overnight success, but it took a long time.
For all its popularity, Pleasanton didn't get rich off of it. Yes, he patented his idea, but they couldn't enforce the patent. You can't prove how anyone's going to use blue glass. But Pleasanton didn't seem too bothered by this. He was, however, bothered by what happened next. The esteemed journal Scientific American questioned the scientific merit of blue glass and dragged his name through the mud.
They wound up eventually doing a series titled The Blue Glass Mania, and where they kind of step by step went through, well, what kind of testing has been done on this? What do people who actually work with glass and, who work with optics have to say about this? And just very, steadily took the whole thing apart.
Some quick context. Quack medicine was rampant at this time. People pretending some bogus treatment was a panacea so they'd get rich. It was a big problem, and medical societies were trying desperately to stop it. So, even though this article was a huge blow to Pleasanton's project, he was more upset that his character was being questioned by a suggestion that he was some sort of charlatan. In response, Scientific American made it clear that Pleasanton was not out to exploit people, but instead was simply ignorant. Months after Blue Mania hit, it went bust.
That's when you first start seeing reports by May of 1877 that not only was blue glass starting to pile up in the stores, but that, a number of dealers had put in all these orders for more of it, and they didn't know what they were going to do because people were suddenly not really buying it anymore. So I'm guessing that by late 1877 or 1878, you could pick up blue glass very cheaply.
Despite how quickly the blue light craze fizzled, for a short time, people ate it up, which begs the question, why? Why was this idea so appealing? Paul Collins says it comes down to a few things, and the first was just timing. The Civil War left people desperate for ways to heal from injury and disease. And even though a lot of charlatans took advantage of this desperation, Augustus Pleasanton didn't seem to be one of them.
He seems to have been really a great idealist. And the history of medicine, and particularly sort of fad medicine from that period, has got a great many people whose motives were not necessarily all that noble.
Another appealing thing about the blue light theory was its simplicity.
In general, with people's health, one of the real challenges around illness is a feeling of helplessness. Or not even helplessness necessarily so much as, well, maybe I can get this cured, but it's going to take, a bunch of surgery. It's going to take a bunch of medications. It's just going to take a lot of effort, and a lot of it will be out of my hands. And this presented something that you could actually do yourself relatively easily. So at some level, I think it gave people a sense of autonomy, of control, that they could actually take control of their health, which is, a very appealing thing. And I think that's why variations of it keep coming back.
Blue light mania might have been over, but our fascination with colored light was still strong. And someone else would soon fill the void with new ways that the light could heal us. Chapter 2. The Guy with the Special Lamps. As the 19th century rounded the corner into the 20th, colored light therapy, or chromotherapy, found even more evangelists. And I use that word intentionally because things started taking on a whole new religious direction. Augustus Pleasanton was a Civil War general who dabbled in medical science in his spare time, but his chromotherapy contemporary was an actual physician who dabbled in the spiritual. His name was Edwin Dwight Babbitt, and his book, The Principles of Light and Color, was published the same year as Pleasanton's. It covered some of the same therapeutic benefits of light and color, but it also pushed a philosophy of life, sort of like a religion. Of course, Babbitt wasn't the first person to tie light to religion. Isaac Newton himself thought the rainbow was divine.
Sir Isaac Newton, was sure that there was more to sunlight than meets the eye. So he trapped a sunbeam and passed it through a prism. And there were the colors of the rainbow, the component parts of white light.
And here enters perhaps the most infamous figure in chromotherapy's history, Dinshaw Ghadiali. Dinshaw, who went by his first name, like, Beyonce, was born in Bombay, India in 1873. And by his own account, he was remarkable. Although, to be clear, we weren't able to verify any of his claims. He says he began school at the age of 2, became an assistant professor at age 11, and began to study medicine by 14. Oh, and he was also a journalist, a skilled composer, an actor, and most relevant to this story, an inventor. Dinshaw considered himself the Parsi Edison. He eventually ended up settling in America in 1911. By 1920, he was entirely focused on his prize invention, the spectrochrome. To the average person, the spectrochrome looked like a metal box on a stand, with a light bulb and colored slides inside. But Dinshaw was clear. He wrote, "The spectrochrome was not a lamp. It is a system," he said. A new, original, and unique science. This unique science could do miraculous things, according to him. Heal a badly burned infant and give them brand new silky skin. Restore the sight of a blind girl. Allow a paralyzed woman to walk again. Dinshaw and the spectrochrome practitioners went on to claim it could cure over 100 ailments, including diabetes, tuberculosis, syphilis, and cancer. By 1946, Dinshaw had sold an impressive 11,000 spectrochromes, bringing in a cool $1 million. Soon, he wrote, there will be a spectrochrome in every home.
My family had a house in Havertown, which is a suburb of Philadelphia, and it was a very normal household. And in this normal household was this spectrochrome machine.
This is author Harvey Racklin.
So I was a child at that time, and in the living room, I saw this big, clunky, blue metal machine that looked like a box on a pedestal with wheels. And it was kind of like a curiosity for me. In this box that was mounted on this pedestal, there was a kind of like an opening. Inside was a light bulb, and you would put over that aperture in this box color slides. Sometimes as a child, I would put the color slides over the opening with the light bulb on and get different colors. As a child, you want to blend colors to make a different color. So it was just a curiosity for me, and I never really gave it any thought. So my father didn't tell us anything about the machine, what it was for or anything really. I never saw him using spectrochrome, and he started using it in the 1950s. And he didn't even talk to us about it at that time.
To young Harvey Racklin, the spectrochrome was just a regular, if slightly weird and cool part of his house. But Dinshaw himself wanted to project the opposite image.
We believe that every cell in your body is an electrochemical machine. Every single one, the billions and billions and billions of them.
This is Dinshaw's son, Darius Dinshaw, speaking on a cable TV program called Round Table in the 1990s. He's sitting with the host at a round table with a bunch of books and pamphlets spread around him, and he's holding up a color wheel and explaining the spectrochrome system.
There are 12 colors that we use basically. Red is basically for the liver. The pituitary is affected by green, digestion by yellow and lemon. Reproductive system by magenta. So every part of your body has a specific function to perform, and in performing that function, it radiates a certain energy. Again, going back to that color wheel in the book, if it's excessive, we use the opposite color. If it needs reinforcement and it's weak, we use the appropriate color.
When Harvey got older, his father finally told him what this machine in their living room was for, and admittedly, he was a bit alarmed.
Honestly, I looked at him in a way like, are you all there? Because how could color lights cure illnesses? But he told us about the story behind spectrochrome and was really kind of blown away. So I read these testimonials and case histories, And I was just amazed by the convictions and the enthusiasm of these medical doctors, as well as laypersons who used it.
Mrs. S.G. suffered terribly with piles. Her family physician and others considered her case unamenable and hopeless. I used the yellow wave on Area 19. Her recovery was so rapid that after her 15th treatment, she went to Atlantic City, where she is still working.
Mr. L.A.G., chronic gonorrhea, green, systemic, and on Area 11. 3 weeks now, patient is all right.
After years of traveling the country, selling the spectrochrome and teaching classes, Denshaw had accumulated a dedicated following, people who were fervent about the spectrochrome system. And it's supposedly those devoted followers who provided the testimonies he published. After reading these, Harvey found himself intrigued by Denshaw's scientific claims.
Denshaw devoted decades of intensive research to determine that the diseased organs have abnormal emanations, or auras, as he said, and that they could be normalated or remedied by applying what he called attuned colored waves, which means color waves of certain oscillatory frequencies that were calculated to coincide with those in cells of the body. So he used spectroscopical techniques and was able to determine the chemical imbalance of diseased organs, whether those imbalances were excessive or deficient. And he determined what color wave radiations could neutralize auras of diseased organs and bring them back to a normal state.
Now, is this explanation backed by actual science? No.
Denshaw is just a very interesting example, a very good example, of how people can buy into total nonsense.
Joe Schwartz is a chemistry professor and the director of the Office for Science and Society at McGill University. The office's mission is to separate sense from nonsense.
You can make nonsense sound very seductive, especially when you have a mostly scientifically illiterate audience. To them, it may not sound so absurd that shining some sort of colored light on you can have benefit. If you choose your language properly and you say, well, and we know that plants need light in order to grow, right?
And even to a scientifically literate audience, certain misleading claims can still be enticing because they promise so much. But selling something you're calling a medical miracle, when it's really nothing of the sort, is illegal, which is why the FDA got involved.
This is a recording of an interview with Walter A. Ernst. The date is March 20, 1979, and the recording is being made at Walter's home.
This is an oral history conducted by the FDA with a man named Walter Ernst, who worked as an FDA investigator from 1929 until 1963. When he started, a lot of his work involved examining fruit, making sure it wasn't sprayed with arsenic. But in 1938, his work changed drastically. Here's Walter.
Many changes had come over the Food and Drug Administration because of the fact of the passage of new Food, Drug, and Cosmetic Act.
For the first time, the FDA had the authority to regulate medical devices. Before 1938, they just fell through the cracks.
One of the largest areas of attention was given to Denshaw P. Gaudiali, who was distributing a spectrochrome machine, a colored light device used to treat everything known to man as far as diseases are concerned.
And it was good for almost anything, wasn't it?
Everything. Even it was supposed to regrow amputated parts of the body.
The FDA sent Ernst to Milwaukee, where Denshaw had a large and committed following.
They had some very enthusiastic operators there. I found that Denshaw had been so active that he had induced the chief of police and the state's attorney to each purchase one of these machines for self-treatment. Of course, they did not want to be mentioned once they found out that it was a fake.
Walter, he had these groups of people. They weren't just people who he sold the machine to, but it was almost like a religious sort of thing.
It was a religious group. A religious group.
Walter talks about Denshaw's followers as being absolutely devoted to him and the spectrochrome system.
At the time I was making my investigations, they had a lot of secret meetings.
Did you ever infiltrate any of their secret meetings?
We frequently would set up a microphone in the meeting room and listen to their meetings, but never did actually get in the meetings themselves because they were strictly closed.
By listening in on the meetings, Ernst pieced together that Milwaukee was a distribution hub for spectrochrome parts.
Once Denshaw found it was impossible to ship the machines interstate.
Did Walter Ernst have any idea that his FDA career would be reminiscent of a CIA career? We'll never know. But this next part seems right out of a spy movie. On one occasion, Ernst trailed a man who left Milwaukee with a carload of spectrochrome parts.
On the way, he left just before dark, and he stopped at a small town and went to a movie while I had to watch for him to come out again. So it was about midnight before he crossed the Milwaukee, Illinois state line, and I stopped him at the line there, but he refused to allow me permission to check his car. Consequently, I was unable to do anything about checking what he had in it.
Walter didn't nail Denshaw that time, but eventually the law caught up with him.
Didn't he go to jail for a while?
Yes, we first got an injunction against him and stopped the shipment, but later on he had to ship more, and he is eventually prosecuted and had to serve time.
Which made him a martyr to
yes,
his people.
He is a martyr.
In 2018, Harvey Racklin wrote a book about Denshaw and the spectrochrome called Color War, Denshaw P. Gadiali's battle with the medical establishment over his revolutionary light-healing science.
Okay, and it wasn't just me. Again, I want to, emphasize that my brother, Stephen Racklin, a physician, had a great part in the writing of this book. He's no longer alive. He had a severe stroke and passed away many years after that. But he credits the long years that he survived after that to spectrochrome, which he used privately.
Does Harvey's defense of Denshaw come from his love for his brother? Did his brother turn to the spectrochrome after hitting a wall with conventional medicine? And if so, can we blame either of them?
It's a grab bag of frustration with conventional medicine, of the hope that is offered by the alternative people. And people are seduced by that, understandably, But so I generally don't blame the people who go down that path, out of desperation. I blame the ones who take advantage.
Harvey Racklin knows that Denshaw's claims were never scientifically proven. The closest thing he can point to are those testimonials, which are not scientific.
You can get testimonials for anything. So what we're looking at with testimonials there essentially is cherry-picked data.
The testimonials could have been completely made up. And even if they weren't, there's still an explanation for why the spectrochrome might have seemed more effective than it actually was.
The placebo effect is very powerful. And, you can yourself become delusional. You forget all the cases where it didn't work and you just remember where there was some success.
Still, Harvey argues that Denshaw's ideas weren't ever exactly disproven either.
The problem that Denshaw ran into is that there was never a double-blind study. All I'm saying is what Denshaw and all these doctors said through all the years. Investigate it, okay? Do a double-blind study. If it doesn't work, so be it. But if it works, this could be, one of the greatest revolutions in medicine. To summarize, was he a quack? Is this all, nonsense? Maybe. Who knows?
But doing proper studies is really difficult, and they're also really expensive. And there's a certain bar of credibility, of scientific plausibility that an idea needs to get funding.
We know a lot about how the world works. We know a lot about biochemistry. We know the kind of things that are possible and, are not possible. And, whatever they say about different color lights is just not scientifically plausible. You can never be 100% certain of anything because there may be some mechanism that, we've never thought about, whatever. But that would have already come to light, as it were, And the classic line that, we use when we teach medical students is, you ask them the question, what do you call alternative medicine that works? And the answer to that is medicine. Okay? Because there is no conspiracy in the scientific medical community to keep effective therapies away from people. I mean, that's just nonsense.
Chapter 3. The Doctor with the Colored Glasses. Given the tarnished history of blue glass and the spectrochrome, you might think scientists stay as far away as possible from colored light therapy. But that's not the case.
My name's Padma Galore, and I am an anesthesiologist and pain medicine specialist. I am professor of anesthesiology and population health at Duke University. I'm also the executive vice chair in the Department of Anesthesiology.
As an anesthesiologist, Padma Galore obviously uses drugs to manage pain, but she wanted to see if she could help manage it in other ways, too. So, like moths drawn to a flame, she started thinking about colored light.
Pain is a biopsychosocial phenomenon. Pain is an experience. And once you recognize that it is an experience and that it has so many different factors that play into it, you start to recognize there may be other facets that we can leverage to change that experience and make things, feel a little bit better.
We all know intuitively that some colors make us feel better than others. And this notion is part of Dr. Galore's work. But there's more to it.
Sometimes the color itself is able to scientifically stimulate the right rods, cones, other receptors through your visual spectrum or on your skin, because we have photoreceptors there too, and just get a pathway to get initiated, which could either make you feel better or inhibit bad signals, right? Signals that we don't want to feel.
Dr. Galore designed a study where patients would wear colored glasses, and she'd see if that would help them to manage pain. Her team had to pick a color they thought would be most effective.
I'll be honest, my feeling was blue. And the reason I thought it would be blue is I love blue. If you go to the beach, those blue waters, that, it's calming. There are some people, you always have the people who like forests more than they like beaches. So green was another color of interest.
So they looked at green, blue, and clear glasses as a control, with two different study populations, one managing chronic pain and one experiencing acute pain. Dr. Galore and her team studied the effects related to pain relief from the different colored glasses. The participants had no way of knowing whether the blue, green, or clear glasses were the ones that might provide relief. And there was a clear winner between the two shades.
Hands down, green seems to make a difference. Now, is this conclusive? Are we completely there? No, like with most things, when you start out, you have to do more studies because you have to have more types of patients, different pain conditions. So we still have a road ahead of us to do this systematically and figure it out.
In clear contrast to Denshaw or even Augustus Pleasanton, Padma Galore is not telling anyone to go out and buy 20 pairs of green-colored glasses. She's not saying that it's a cure-all, and she's really upfront about not understanding why it seems to work.
I think there's so many things we don't always know exactly how they work in medicine, right? But as long as they're doing good things and not doing harm, it's still good to use them. That said, we should keep looking to understand the mechanism. And the reason for that is if we understand the mechanism, we can make it even better. Like with any scientific mind, right? Discovery. It's all about discovery. We've got to find out what's going on.
But Dr. Galore isn't the only one asking questions. Remember Lynn Godley, the light-obsessed artist whose exhibit mesmerized people? Well, she kept thinking about that experience she had back in 2011 and wondered if she could intentionally recreate the response people had. So she started doing some research, starting with a book called Your Brain on Art.
And, it is just filled with study after study after study of how beneficial art is, whether you're the one creating the artwork or you're viewing it.
Lynn wanted to create a study that would investigate the health benefits of light and color. It took some time and some kismet, like the time the design school she worked at merged with a medical school. And not just that, a medical school that just so happened to have a light research program. And what came next was the creation of the Jefferson Center of Immersive Arts for Health.
So it's a broad range from different programs, from public health, from behavioral medicine, from psychology, from autism and neurodiversity, that are all involved in, doing some research on using dynamic light or immersive experience.
The center has already collected data around viewing light and color in pieces of art. The first was an exhibit of 11 installations called The Waiting Room. It was open in Center City, Philadelphia at the end of 2022.
And we had seating at each installation, and the research team put together a survey. So there was a QR code next to each installation that people could log in and just answer some questions like, how long did you sit with this installation? What was your experience? How would you describe it? And surprisingly, people stayed for a long time. I mean, some of the installations, they stayed up to 3 hours in this gallery just sitting with one piece. And overwhelmingly, the words used to describe their experience was feeling calmer, feeling more introspective, feeling more peaceful.
Lynn's team just published the results from that first study, but they didn't stop there. They went on to test out the effects of light and color on students during high stress points during the semester, and they're continuing to try and find more intentional and data-backed ways of thinking about how we use color and light.
How do we make the spaces that we reside in, that we spend time in, that we work in, more healing for us? It's critical. It's really critical to start taking this more seriously, because you look around and everybody's just ready to tip over. So, I think that anything that we can do, and this is it, doing this is not going to cure cancer, right? It's not going to solve all the problems of the world, but if it can lower stress, because stress also makes it harder for us to heal. It increases everything bad that happens in our body. And so, how might we slow that down? And if making artwork can be part of that, that's good.
So there are still more questions than answers. And no one has suddenly unlocked the secret to the healing power of colored light. None of this means that Augustus Pleasanton's blue light worked, or that Denshaw's spectrochrome could do everything it claimed. But it's in our nature to wonder. Maybe in 100 years, we'll still be asking these questions. We'll probably still be fascinated, because light can have profound impacts on our moods, even if it can't cure our diseases. Distillations is produced by the Science History Institute. Our executive producer is Mariel Carr. Our producer is Rigoberto Hernandez. And our associate producer is Sarah Kaplan. This episode was reported by Sarah Kaplan and mixed by Jonathan Pfeffer, who also composed our theme music. This episode was inspired by our museum exhibit, Bold, Color from Test Tube to Textile. You can learn more at sciencehistory.org/bold. You can find all our podcasts as well as videos and articles at sciencehistory.org/stories. And you can follow the Science History Institute on Facebook, Twitter, and Instagram for news about our podcast and everything else going on in our free museum and library. For Distillations, I'm Alexis Petrick. Thanks for listening.